This particular question is a rates question where you actually have to plug in the answers to solve it. I mean, it's possible to solve it another way by just doing the algebra, but what we're going to address is the fact that doing the algebra is going to be prohibitively difficult and long. So this is a situation where we want to recognize, and for that matter recognize quickly, that the easiest thing to do is going to be to identify which of the answer choices actually would be easy to plug in and then try plugging those in. And the nice thing about that is that once you realize that you can look at the answers and see which ones would be more fitting for the question itself, then you'll see that they've actually done you a favor and they've made one of those answer choices the actual answer. So answering a question like this is essentially about test strategy. It's just understanding this is going to be too difficult for me to do step by step in the time that I have. Is it possible to plug in answers then? Which answers would I look at? Which answers would I say are valid to plug in and which ones aren't, just out of simple difficulty of the numbers or ease of the numbers? What we'll see, so let's take a look at this. I'll do it first with the plug-in method, and then we'll do it again where I do it all the way out. Now that's why this video is going to be quite long. Now the first thing you want to do with any of these questions is just give it a quick read. Just skim it, see what it's talking about. Traveled upstream a distance of 90 miles at an average speed of v minus 3 miles per hour, and then traveled the same distance downstream at an average speed of v plus 3 miles per hour. The trip upstream took half an hour longer, so that's going to be a number that we use, of course, this half an hour. If that trip took half an hour longer, now note that that's going to be a number that we use because we want everything in hours and miles per hour. So that half an hour is just a 1/2 essentially. The trip upstream took half an hour longer than the trip downstream. How many hours did it take the boat to travel downstream? Now remember, when you're writing a rates question, be sure to write your units. It's going to save you hassle in the long run. A distance of 90 miles, that's our distance. And remember, distance equals rate times time always. 90 miles, if we go upstream here, all right, 90 miles is going to be the rate of v minus 3. This is the slower rate, v minus 3 miles per hour times t half an hour longer, so t plus 1/2 hours, where we're setting t as the shorter time, the time it took to travel downstream, okay? So then we would have the downstream. Of course, that's going to be 90 miles again. And then that's v plus 3 miles per hour times t hours in that case. So we don't actually need to write the bracket there. So just double check all your units. If all of your units cancel out for a rates question, then you know that you can proceed. If they don't cancel out, then you have to adjust something. In this case, it's fine. What we can do, of course, the 90 miles and the 90 miles are the same, so we could set these equal to each other. Essentially, we're going to end up with a statement like this. We're going to have v minus 3 times t plus 1/2 is equal to v plus 3 times t, okay? If you look at this, this is going to give us something that is going to be incredibly difficult to work with. Vt plus 1/2 v minus 3t minus 3 over 2 equals vt plus 3t, etc., etc. What you're going to end up with, basically, is you've got one equation here, and you've got two unknowns still. What you're going to have to do is you're going to have to get the v in terms of t, basically, or something like that, and then plug that back into one of these equations in order to solve. It's going to take forever. We don't want to do that, all right? I'll show you how to do it later on, but honestly, we don't want to do that right now. So the question is, at this point, if we're trying to find a different way to do it, what is that way, and how do we do it? Well, consider plugging in the answers and just see what happens, right? So how would you pick an answer to plug in? Well, the point is this. We have a 1/2. We need to be thinking about something. So, if we did 2.0, 2.5, 3.0, these numbers would be easy to add a half to, and that would make the math really simple and quite straightforward, as GMAT arithmetic tends to be. I would aim towards something that either ends with a 0.0 or a 0.5, and luckily we've got only one answer that ends with a 0.5. They're all descending, so basically if we see that this is too much, then we can start working our way down. Anyway, I'm just going to start with this and see what happens. What we can do is we can basically just ignore all that stuff. once we have the numbers here, we've got 90 equals v minus 3 times t plus 1/2. Now, this is the how many hours, so this is a t, okay? So let's just take this one. We'll draw this one down here. 90 is equal to v minus 3 times 2.5 plus 1/2, so that's just 3, right? So 3v minus 9 is 90, so 99 is 3v, and v is 33. All right, this one's v minus 3, so that's 30 miles an hour, and this is v plus 3, so this is 36 miles per hour. So what we'll do is we'll just take that one and test it. If it works for 36, then that's our answer. So let's just say 90 equals 36. So basically what we're trying to do here is see that if we take v as 33, we assume v is 33 from the work that we've done here, and if we plug that into the other one and find that it works, where basically we plug 33 in and we get t is 2.5, then this is going to be our answer. So 90 is equal to v plus 3, so that's 36 times t, and then 90 over 36. So, what's the easiest way to take that out? Probably just drop it by 6s, so you get 15 over 6, and then drop it by 3s, so you get 5 over 2, which is, lo and behold, 2.5. We plug in 2.5 here, solve for v, plug the v in here, and compare the t. If the t is the same, that's our answer. And look at that, it is our answer, 2.5. That's all you have to do in a question like this. There's really nothing else to be done. Now, I'm going to show you the algebraic way. You don't have to really pay attention to this or follow it all the way through, but the important thing is that you can see that it is possible to do if you had unlimited time. I mean, that's an option. If you were trying to do this as your physics homework, then of course you show all the work and you do it. You can't just get away with stuff like this, except on GMAT. So we start at the same place. I mean, we've written the equation out here, and what we're going to do is basically just draw everything through here. So this one's going to be 90 is equal to, I'm just expanding this with FOIL, so vt plus 1/2 v minus 3t minus 3 over 2, okay? And 90 equals, thankfully, this one's a bit easier, vt plus 3t, okay? Of course, we're making those equal because, 90 equals 90. So vt plus 1/2 v minus 3t minus 3 over 2. And then we'll see that that's equal to vt plus 3t. Look at that, vt cancels right out. Okay. Simplest thing probably is to multiply both sides by 2 at this point. So I get v minus 6t minus 3. I'm just trying to get rid of fractions. I don't like fractions in these. So v minus 6t minus 3 equals 6t. So what we're going to get there is 12t on this side, so we get v minus 3 equals 12t, or if you bring it over, v minus 12t minus 3 equals 0. And if you've got sharp eyes, you're going to see that this is actually a quadratic. So what we would want to do is to take one of these equations, presumably this one, because this is the easier of the two, solve for v in terms of t, okay? Because I want the answer to be t's. These are t's, right? Solve this one for v in terms of t. So remember, we're trying to solve for the v here so that we can plug that back in. What we're going to do is solve for v in terms of t. That means that we're going to factor the t out. That's v plus 3 is 90. And then we'll get 90 over t is equal to v plus 3. And lo and behold, we get 90 over t minus 3 is equal to v. At this point, what we're going to look at is just figuring out how we can plug all of this stuff into all of this stuff. What I'm basically going to have to do is find a lot more space to do this. I'm just going to take what I've got here and I'm going to start a new screen. That's how much space this is going to take. Remember our values were v equals 90 over t minus 3. And the other value was the thing we're going to plug this into, which is v minus 12t minus 3 equals 0 to get our quadratic, okay? So I'm just going to take that, sub in, and it's going to become a lot clearer. 90 minus 12t squared minus 6t equals 0. So then we'll rearrange it, of course, to make it simpler. Move these guys over to the other side. So that's 12t squared. I'm going to keep it on the left side, but I'll just change the signs. 12t squared plus 6t minus 90 is equal to 0. Obviously, we have some common factors in there, so the easiest thing for us to do probably is just to divide everything by 6. So what we'll do is 15 here plus t, and then 2t squared, and then just have to look at the factors here and figure out what factors we need to break that quadratic. So it's going to be 2t and t, okay. Because this is 15, I mean, it's almost certainly going to be 3 and 5. The only other options would be 15 and 1, and there's no real reason for us to assume that this is going to get, that we're going to be able to get this t out of 15 and 1. I would imagine what we're looking at then is, okay, we get a 3 here, so that's going to give us a 6, and that's going to give us a 5. So the plus 6 minus 5 would give us a plus t, basically. Which then gives us, okay, so 2t minus 5 equals 0, so that's going to be t equals 5 over 2, 2.5. Oh, look at that, answer A, after all that work. Or we get t equals minus 3, which essentially means that the boat arrived at the destination before it left. As usual, avoid the negatives when you're dealing with geometry or rates or a negative cost for some kind of item, because, you know, just like the boat arriving before it leaves, you're not going to get a store to pay you to take their item or something like that. They're just absurd as far as GMAT's concerned, so you can ignore those. But yeah, after all that work, we managed to get 5 over 2. And as you see, it would have been simpler just to plug in. If you liked the video, if you found it useful, then I would really appreciate it if you check out some of our other material. That's at yourgmatcoach.com. The link is below. If you want to subscribe on YouTube, that's always helpful as well. We have lots of video courses and other books that you can look at there, and of course a blog that's got more information like this. It would be great to see you there, and I'll see you in the next video. Thanks a lot.